Hello everyone, welcome back to the series of Complete Python specifically designed for GATE, data science and artificial intelligence. In this session, we will discuss about the time complexity of set operations. In the previous lecture, we discussed about various set operations. In this class, let's find out the time complexity of those set operations. So let's move on and check out all the set operations time complexity one by one. Starting with the in operator, which is used for searching the element inside the set. So here we are searching this key element inside the set S. How much time that will take? That will take constant time. Why that is taking constant time? Because set are implemented at the back end using hash table, and hash table take constant time for searching, for insertion and for deletion in average case. Okay, so searching, here we are performing the search operation, so searching will take constant time, set take constant time to search the element. Okay, to search the element inside the set we take constant time. Fine. Okay, another operation is the not in operation. So not in operation, this statement will return true if this key value is not present in the set. Okay, so still this is searching we are doing. Okay, we are searching, this should not present in S, then only we will return true, but still searching is going on, and searching again will take how much time? Constant time to perform. Next operation is the equivalent operation. We are comparing two sets, set 1 and set 2, we are comparing them. If all the elements of S1 is matching with all the element of S2 and number of element in S1 and S2 are equivalent, then only we say that two sets are equal. Okay, and how much time this will take to find out two sets are equal? Simply what you can do, you take the element of S1 and compare one by one all the element of S1 into S2. If all are matching, then only you will say two sets are equal. But note down one more thing, the length of S1 and S2 should also be equal. Fine. So how much time this will take? This will take order of length of the set. So we are assuming that the length of both the set S1 and S2 is equal. So this will take order of length of S time. How much is the length of the set? Any of the set, because both have the equal length. Then we need to just pick one set, comparing all the element of that set into the other set one by one. So that will take order of length of S time. That's it. Another operation is opposite of equivalent, that is not equivalent. Here also actually this will take order of length of S time. Same reason, here also you need to compare all the element of one set into the another set one by one. Total number of elements will be length of S. This is the length of S. This much elements will be there. You need to compare all the elements. That's it. Fine. Okay. Next one is the subset operation. Here subset means all the elements of S1 should be present in S2. So then only S1 is subset of S2. One more condition can happen over here is that S1 and S2 can have equal number of elements. See, equal is here. So both can have equal number of elements. But one thing is sure, all the element of S1 is present into S2. Then only we can say that okay, S1 is the subset of S2. So how much time this will take? What you need to do? You take one by one all the element of S1 and search it inside into S2. Take one element from S1, search it into S2, another element, search into S2. Searching take constant time. So total element you are searching is S1. That depends upon the length of S1. So this is the time complexity. That's it. Length of S1. This is the time complexity to find out if set 1 is subset of S2 or not. That's it. Another operation which we perform is the proper subset. In proper subset, one thing is confirmed, the length of S1 will be less than the length of S2. Then only S1 can be proper subset of S2. One thing is this. Second thing, all the element of S1 should be present into S2. To be S1, if want to be subset of S2, then all the element of S1 should be in S2. And second thing, the size of S1 should be smaller than S2. Okay, so how you will find out? Okay, S1 is proper subset of S2. Simple, again the same way, pick one by one all element of S1 and search into S2. So this will, okay, the same one, length of S1, because you are picking one by one all element of S1 and searching into S2. So number of operation is length of S1. Next operation is the superset. What do you mean by superset? Superset means all element of S2 should be present in S1. All element of S2 should be present in S1. Then only you can say that, okay, S1 is the superset of S2. Okay. One more thing over here we can add is that the number of elements can be equal. In both the sets, S1 and S2 here, number of elements can be equal, but one thing is confirmed. All the element of S2 should be in S1. If S1 want to be the superset of S2. So how you will find out that, how you will find out that thing? Simply what you can do, take one by one all the element of S2, search it into S1. Take one element from S2, search it into S1. So keep doing that. So we can say that, okay, the time complexity will be length of S2 this time. Done. Next one is the proper superset. Proper superset means all the element of S2 again should be present in S1. One thing. Second thing, the size of S2 should be smaller than size of S1. That is confirmed. The size of S2 should be smaller than the S1. Then only that can be proper superset. So S1 can be proper superset. Its size should be greater than S2. And all the element of S2 should be present in S1. So how you will find out, okay, if S1 is superset of S2 or not? Simple, again the same way. Take all the element of S2 one by one, search it into S1. So the time complexity will be same, that will be length of S2. Done. Next operation is union operation. Union operation is just taking all the element of S1 and S2 into a new set, except the duplicates, duplicate elements is not taking. Means the elements which are repeating in both the sets, they are taken one time. So how much time this will take union operation? Union operation, actually what you can do is, you can take all the element of S1 first. Okay, you can take all the element of S1. How much time that will take? That will take the length of S1 time, plus now you can take all those element of S2 which are not present in S1. Okay, so maybe you may consider all the element of S2 because they are not matching with S1, and even they are matching, you need to compare. So how many further operation you need to perform? Length of S2. That's it. So this is the time complexity of union operation. Length of S1 plus length of S2. You need to consider all the element of S1 and S2. So definitely you need to process total element of S1 and S2. So the time complexity will be order of length S1, length of S2. Let's move on. Next operation is the intersection operation. Intersection operation is finding the common element between S1 and S2. So what can be the efficient way to find out the common element? See what I can do. I can take the minimum length set out of these two. Who is having the minimum length? So let me find the minimum of S1 comma S2. So find the minimum, and now let's suppose S1 is the minimum as compared to S2. S1 length is smaller than S2. Then take one by one all the element from S1, search into S2 which are common. Consider that. That's it. So the time complexity will be depend upon the size of the minimum set, the set which have less length. So the time complexity will be order of minimum of length of S1 comma length of S2. Length of S1 comma length of S2. Next operation is the difference operation. Difference operation is just taking all the element of S1 except those which are repeating in S2. Okay, taking all the element of S1 except those which are repeating in S2. So how you will find out the difference? Simply what you can do is you can take the element from S1 and search it into S2. So which are repeating, don't consider that. Which are not repeating, consider that. That's it. So this will also take order of length of S1 time. Done. Last operation, symmetric difference. Symmetric difference. What do you mean by symmetric difference? This will consider all the element of S1 and all the element of S2 except those elements which are common between S1 and S2. So this will discard the common element between S1 and S2 and take all other elements. So how much time this will take? This will take, okay, let me write the time complexity first. The time complexity will be order of length of S1 plus length of S2. Why this is taking this much time? Because you need to consider all the element of S1 and all the element of S2 except those which are common. So what you can do, you just pick S1 first, this set, take one by one element from S1 and search it inside the S2. If they are repeating, don't consider it, otherwise consider them. Similarly, you can do with S2 also. So those elements which are not repeating, consider them. So you need to process all the element of S1 and S2. So this will take how much time? Length of S1 plus length of S2. Done. We're done with the time complexity of all the operation. Oh yes, we completed one more session. Stay tuned. We will meet back in the next class.